Okay, thank you for watching my video. Again, if just skip ahead to any problems that you need to check. So for number one, you want to isolate what's being squared. So you first need to subtract this 3 from both sides, and then you get 1/2 x minus 6 squared equals 18. And then to get rid of the 1/2, you multiply by 2, and then you get x minus 6 squared equals 36. And then now that what's being squared is isolated, now you can square root both sides to untrap x, and then you get absolute value of x minus 6 is equal to square root of 36. And then now from there, you can make two equations. So you have x minus 6 equals positive 6, and x minus 6 equals negative 6, because square root of 36 is 6, and because you have an absolute value, you make two equations for positive and negative. And then you add 6 to both sides, and then you get here you get the answer x equals 12, and here you get the answer x equals 0. And those are your two answers. Okay, now for this one, it's quadratic, so you want to try to see if it factors. So make your area model in diamond because you have something in front of the x squared. And then you put 4x squared here, negative 5 here, from here and here. You multiply them together and get negative 20x squared. And then you put negative 8x down here. And then two things that multiply to negative 20x squared and add up to negative 8x are negative 10x and 2x. And then you put those in your area model. And then you figure out your dimensions of your area model. So you can see along here, like 2x goes into both of these terms, and then 2x times 2x is 4x squared, 2x times 1 is 2x, and 2x times negative 5 is negative 10x, and then you can see negative 5 times 1 does equal negative 5. So then this factors to 2x minus 5 and 2x plus 1. And then once you factor it, then you want to set each of your factors equal to 0. So 2x minus 5 equals 0, and 2x plus 1 equals 0. And from there, you'll get your two answers. So you add 5, and then you get 2x equals 5, and then divide by 2, and you get x equals 5/2 as one of your answers. Here, let me just. And then 2x minus 1, you subtract 1, and you get 2x equals negative 1. And then divide by 2, and you get negative 1/2. And those are your two answers. Okay, now for this one, you can see you have like fractions. You want to get rid of some of them by multiplying by a number that is divisible by 4 and 3. So you multiply everything by 12. They should go away, and they do. So 12, and then you just have the numerators here. So you have the numerator like 3x, and then 12 divided by 4 is 3. So you have 3 times 3x. And then you do 12 times negative 2, so that's negative 24. And then you have x, and then 12 divided by 3 is 4, so 4 times x. And then you do 12 times 3, which is 36. So then you have 9x minus 24 equals 4x plus 36. And then you subtract 4x from both sides, and you get 5x minus 24 equals 36. Then you add 24 to both sides, and you get 5x equals 60. And then you divide by 5, and you get your answer, x equals 12. Oops. I get yellower and yellower in my boxes. Okay, for number 4, it's similar to number 1 in that like x is kind of trapped. Here, x is like trapped under a squared, so you gotta isolate that before you can undo the squared. And here, the x is trapped under the root, so you gotta isolate this before you undo the roots. So you want to subtract 4 from both sides, and then get 3 times square root of 2x minus 1 equals 15. Then divide everything by 3, and then you get square root of 2x minus 1 equals 5. And now the root is isolated, so now you can undo the root by squaring both sides, and then you get 2x minus 1 equals 25. Then you add 1 to both sides, and you get 2x equals 26. And then divide by 2, and you get x equals 13. And there you go. That's the answer. Okay, let's go on to the next problem. Okay, so this one's an absolute value problem. So it's again like the 1 and 4. You need to isolate the absolute value first. So add 11 to both sides, and then you get negative 2 times the absolute value of x minus 3 equals negative 4. Then divide both sides by negative 2. And then you get absolute value of x minus 3 equals positive 2. And then you always want to see, like, okay, once you isolate your absolute value, does that make sense? Your absolute value should always equal a positive number. So it does make sense. So now you can make your two equations. You have x minus 3 equals positive 2, and x minus 3 equals negative 2. And then you add 3 to both sides, both times. You get your first answer as 5, and your second answer as 1. Okay, so now you want to do something similar, but it's an inequality. So there's some extra things we need to keep in mind. But first, we do need to isolate the absolute value. So subtract 5. So you get 2 times the absolute value of 5 minus x is greater than 14. Then you divide by 2, and then you get absolute value of 5. Oops. Minus x is greater than 7. And then from here, you make two equations. So you have 5 minus x is greater than 7, which is, or two inequalities, because it's an inequality. So you make 5 minus x is greater than 7. So it's similar to this one where you basically take away the absolute value and leave it the same. But the second one, because it's an absolute value, you need to make this 7 negative 7, but then because it's an inequality, that triggers the sign to change. So those are the two inequalities you need to solve. So then you subtract 5, and you get negative x is greater than 2. And then you divide by negative 1, and that causes, you multiply or divide by a negative number that causes it to flip the sign. So then you have x is less than 2. Oops, let me write that. Let's write it down here, or up here. So you have 1 is x is less than 2. And then now we'll do the other one. So then we subtract 5, and we get negative x is less than negative 12. And then you divide by negative 1, and that causes it to flip the sign. So it's x is greater than positive 12. And then you just plot them on the number line. So if you go by 2s, for instance, then actually go by 2s. Okay, so x is less than 2 means that you want to do an open dot at 2 and then shaded this way. So that's this one. And then x is greater than 12, and then open dot at 12 and shaded greater than 12. And then that's your answer, are these two inequalities. So x is less than 2 or x is greater than 12. Okay, let's do this one, which is a quadratic inequality. So for that one, you need to set it equal to 0. So let me add 3 to both sides. And then you get 6x squared minus 15x plus 6 is less than or equal to 0. And then let's make this a little easier to factor. So you can see that they're all like divisible by 3, like 6, 15, and 6 are all divisible by 3. So let's just go ahead and divide that by 3. And then we get 2x squared is less than 5x plus 2. Okay, now we're going to factor that. So I'm going to do that over here. Okay, so we put the 2x squared here, then the 2 here, you multiply them, you get 4x squared, and then you put this middle term here. So 2 expressions that multiply to positive 4x squared and add up to negative 5x, or negative 4x and negative x. And then their dimensions, you can see along here, you have like 2x in common, then 2x times x is 2x squared, x times negative 1 is negative x, and 2x times negative 2 is negative 4x. So, and then that works. So this factors to 2x minus 1 times x minus 2 is less than or equal to 0. Okay, and then what you want to do is you want to do like a sign analysis. First, you want to figure out where is your quadratic 0. So you want to set 2x minus 1 equal to 0 and x minus 2 equal to 0. And then you get x equals 2 here, and then you add 1, and then divide by 2, and you'll get x equals 1/2. Okay, so that's when your quadratic is equal to 0, right? We want to find when our quadratic is less than or equal to 0. So these are our boundary points. So we want to put these on our graph. So you have 0. So 1/2. And you want to do solid dots because it's less than or equal to. So 1/2 is here, so solid dot. 2 is here, solid dot. Okay, and like I said before, right, that kind of your boundary point splits your number line into like 3 sections that you need to check, because we want our to know, we want to shade the sections where our quadratic is less than or equal to 0. So where if we plug in a number from the number line into our quadratic, if it makes our quadratic negative, that's an area that we need to shade. So we want to pick a number that's easy to plug in. So like here, if we plug in 0, for example, we plug in 0, we plug it into this one, right? We're gonna get negative in our first parentheses and negative in our second parentheses. So it makes the whole thing positive. Now we want to pick something in our other section, so like 1. So if you plug in 1 here, you'll get like 2 minus 1, which is positive. And then if you plug in 1 here, you get 1 minus 2, which is negative. And a positive times a negative is negative overall. And then here, if we want to test something like 3. So if we plug in 3 into this parentheses, we'll get positive. And then if we plug in 3 minus 2 into this parentheses, we'll get positive. And a positive times a positive is positive overall. And we want the areas where it's less than or equal to 0. So when it's negative. So the only section that we end up shading is this section. And so our answer is that section, which is when x is between our 2 boundary points of 1/2 is less than 8 and 2. So that's our answer. Okay, this one, it's like a compound inequality. Now you can split them up, but I just like to solve it all together. So you want to isolate the x from the middle. So you need to add 7 in the middle, and then you need to add it on both sides here. And then you get 15 is less than 3x, which is less than 27. And then you divide everything by 3. And then you get 5 is less than x, which is less than 9. And then that's your answer. So similar, like, right, to this inequality, right? 5 and 9 are my boundary points. So that's what I need to put here. So 5, 6, 7, 9. And because it's just less than, right, not equal to, you do open boundary points. And then it's shaded in between. And there you go. Okay, next problem. Okay, so this is a system of equations, and it's set up to solve by substitution because you see that you have y all by itself. So you want to take this expression and plug it in for y here. So then you have 2x minus 3y, and so now, since y is equal to 3x minus 8, we put that here. And then equals negative 18. And then we solve. And when we get the x value, that's going to be our x coordinate of our point of intersection when we graph. So distribute this negative 3, and you get negative 9x plus 24 equals negative 18. Then you add those, you get negative 7x plus 24 equals negative 18. Then you subtract 24 from both sides, and you get negative 7x equals negative 42. And then you divide both sides by negative 7, and you get x equals 6. So our point of intersection is going to be 6 something. So to figure out what that is, you plug that in to either of these, but it's probably best if you dot y, because y is already isolated. So it'll be y equals 3 times 6 minus 8. So then that will be 18 minus 8. So you get 10. So our point of intersection is 6, 10, right, which is right here. Okay, so now let's graph this. So this one's easier to graph because it's already in y equals mx plus b form. So this is your slope, and that's your y-intercept. Your y-intercept is way down there. So we know it has a slope of 3. All right, so looks like this. So here's our line. I'm going to do. Okay, and then for this one, you want to solve for y. So subtract 2x, and then you get negative 3y equals negative 2x minus 18. And then you divide by negative 3, and then you'll get positive 2/3 x plus 6. So you have a y-intercept of 6 and then a slope of 2/3. And then you can see it does intersect here. And so there's my line. Okay, and then for this one, they're both equal to y already, so you just set them equal to each other. So you have x squared plus 5x minus 35 equals x minus 3. Now, because this is a quadratic, you want to set it equal to 0. So subtract x, add 3, and then you get x squared plus 4x minus 32. And then that one quickly factors because you don't have anything in front of the x squared. So negative 32 goes at the top. This 4 goes at the bottom. And then 8 and negative 4 multiply to negative 32 and add up to 4. So it factors to x plus 8. And x minus 4 equals 0. And then those are where you get your x values. So whatever makes this 0, right, is going to be your answer. So negative 8 and positive 4. So that means you're going to have 2 points of intersection, one at negative 8 something and one at 4 something. Now you could plug them into this one, but obviously this is easier to plug in. So plug it into here. So we have negative y equals negative 8 minus 3. So that's negative 11. And then we'll do the same thing again for 4. So that's y equals 4 minus 3, which is 1. So that'll be 1. So our one point of intersection is -8. -11, and then the other one is 4, 1. Okay, now let's graph this line first. It's a little easier. So it has a y-intercept of -3 and a slope of 1. So we'll connect the line. Okay, and then the parabola, this one you should probably like see, if it factors, and it does, to x plus oh, excuse me, it doesn't factor. Um so what you want to do then is you can plug in some numbers just to get your shape. So like and then so you also get 3, -11. Oops. And 2 is -21, so that's not very helpful. And then here you get, so you can use like Desmos to support you for finding points. It looks like this. Okay. All right, let's next go to the next problem. Okay, so again, you want to set these, since this is a system of equations, you want to set them equal to each other. So root x plus 2 is equal to 1/2 x. So we want to square both sides, and then you get x plus 2 equals, and you gotta be careful, when you square 1/2, you get 1/2 times 1/2, which is 1/4. And then let's get rid of that fraction. So multiply by 4, and then you get 4x plus 8 equals x squared. Then set it equal to 0. And well, this doesn't factor, it's actually pretty gross. So let's just skip ahead to the graphing part. So this one, the square root of x minus 2, right? The regular graph, right, like of the square root of x, right, looks like this. And so, because the square root of x of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. So that's why that looks like that. And then x plus 2 is to the left 2, right, using your transformation. So then here's my shape. Oops. There was an undo button. That would be nice. Okay, and then half x, right, that has a y-intercept of 0 and then a slope of 1/2. So you can see they intersect here, which isn't the nicest of numbers. So you can use a quadratic formula, and you would he would get x equals you would get negative 1.464 and 5.464. If you use the quadratic formula with that quadratic, but this one ends up not working with this graph. You can see there isn't, when you go down, it doesn't intersect there. So then the answer is 5.464 something. And if you plug it into either of those, we'll get a y value of 2.732. Okay, and then this one is a system of inequalities, so they might look something like this. So this one's an absolute value function where your vertex is negative, it's the opposite of this and the same as this. So it's -3, -2. And your slope is whatever number is in front of the absolute value. But since there isn't anything, that means your slope is 1. So then you, that's the slope of your right ray, and then you do your left ray. Okay, now since it's less than or equal to, you connect your dots with a solid, lines. And since it's less than or equal to, that means you would shade below. But remember, this is a system, so I just mark it because you end up shading like the overlap, right, in the end. And then this one's a parabola that has a vertex. Opposite of this one is 1 and then 5. So 1, 5 is here, and then it's upside down. And then so you connect it with like a dotted, and this one says greater than, so you shade above the parabola. And you can see the overlap ends up being these sections over here. So overlaps there and here. Because you can see both of these sections are above the parabola but below the absolute value. Okay, so for this one, I mean, what helps is first determining like what kind of thing it is. So these are both lines. So this one has a y-intercept of 3 and then a slope of -2. So it'll be -2x plus 3. And we'll leave it y there. And then this one has a y-intercept of -3. And then it looks like it goes up 4 and over 1. So it'll be 4x. And then you want to just determine the sign. So you can see like that's Oops. So this one is dotted, and you can see the shaded area is like above this line. So then if it's dotted and above, it's just greater. And then this one is, you can see, is a solid line. And then you can see it's also above this line. So then you do greater than or equal to. And then that's your system. Okay, and then for this one, right, this one's a line which has a y-intercept of 3. And it looks like, ooh, if you go down, a slope of -2/3, so -2/3 x. And then you can see the shaded area is below the line and the line's dotted, so it'll just be less than because it's below and dotted. And then for this one, right, this parabola is dotted, and then you want to find out what that vertex is. It looks like -1, -4. So then you do the opposite of the x1. So the vertex is -1, so you +1 squared, and then -4 for the y value of the vertex. And you can see the shaded area is above the parabola. And remember, the parabola is dotted, so it's just greater than, not greater than or equal to. And that is your system. All right, thanks for watching.